All right, so as I was saying, once you've decided whether or not you want bacon or whether or not you want sausage or eggs or beans, then the rest of the servings will just be spam, until you have 5 servings. Okay, so if you choose bacon and sausage, then you need 3 more items and they'll just all be spam. And if you choose beans, eggs, and sausage, you need 2 more items and they'll just all be spam. So, um, your only decision is whether you want bacon, whether you want sausage, whether you want eggs, and whether you want beans. And there's only 2 choices. You either want it or you don't. So this ends up being 2 to the fourth. Ooh. 2 to the fourth. All right. And what's 2 to the fourth? Well, it's 2 times 2 times 2 times 2, which is 16, which is what we got before. So that's a good thing. We get 16 this way as well. So it's a good way to check your answer. We got 16, 3 different ways, so we're pretty confident that that is probably the answer. But what's really interesting, and I want to continue on a little bit. I've got the answer, but the really interesting thing is that here we figured up the sum of 4 choose 4, 4 choose 3, 4 choose 2, 4 choose 1, and 4 choose 0, and we got 16. And so let's write that out. We had 4 choose. I don't know why my pen's not working quite right. 4 choose 4, and we had 4 plus. Ew, what's going on with my pen? 4 choose 3. Oh, come on. Ew. Okay. Plus 4 choose 2 plus 4 choose 1 plus 4 choose 0. Oh goodness, I'm having a lot of trouble with this pen. I don't know what's going on. Yeesh, that's not good. Alright, and we add those up and we got 16, which is equal to 2 to the fourth. Alright? And the really interesting thing, if I can write it without... I can't believe this. Anyway, the really interesting thing is that it works for any number. For this, we could do 5, choose 5, plus 5, choose 4, and so on, all the way to 5, choose 0. This is really bad. And we would get 2 to the fifth. That is cool. That's supposed to be a 5. It looks a little like an S, but that's supposed to be a 5. Alright, so we have, n choose n plus, goodness, n choose n minus 1 all the way, it's supposed to be a plus. Alright, all the way to, it's supposed to be a plus, n choose 0, and that's equal to 2 to the n. Alright, that is a cool relationship, and if you're inclined, you can test that. Another thing with combinations is that I don't know how many of you have experience with Pascal's triangle, but it looks something like this, where each row below has the sum of the 2 numbers above it, right? Oops, that's supposed to be a 1. I don't know what is going on here. This looks like a really bad Pascal's triangle, but 1, 3, 3, 1, 1, 4, 6, 4, 1. Does that look familiar? This is a 1. That's what we got up here for 4 choose 4, 4 choose 3, 4 choose 2, 4 choose 1, 4 choose 0. So this row of the Pascal triangle is exactly um, what we got when we calculated all those combinations of 4 choose whatever, okay? And if we sum all the numbers of the Pascal's triangle, we get 2 to the 4th. Oh man, 2 to the 4th. And if we sum all of these numbers, we get 2 cubed. That's supposed to be a 3. Alright, right? Because 2 cubed is 8, so we get 1 plus 3 plus 3 plus 1 is 8, right? Same thing for this one. If 1 plus 2 plus 1 is 4, which is 2 squared. Alright? Very cool. Alright, so I don't know what's going on with my pen. This looks like a mess, but I got the answer for you 3 different ways, right? We got the answer 3 different ways, and they all came up to 16, and it's really interesting to look at all the combinatorial identities that are in Pascal's triangle. So, find some more patterns in Pascal's triangle.